Let us solve question number 13, guys. So this question is from periodic table and it is based on ionization enthalpy. Let us go through the question. The 5 successive ionization enthalpies of an element are 800, 2427, 3658, 25024 and 32824 kilojoules per mole. The number of valence electrons in the element is 3, 4, 2 and 5. Now if I look at this data what is given to me, I clearly see that these ionization enthalpies are given, okay, and between the third and the fourth ionization enthalpy, that is ionization enthalpy 3 and ionization enthalpy 4. So this is 3658 and this is 25024. Now if you can see this, there is a very big jump, guys, right from 3658 to 25024. There is a very huge jump, guys. So what does that indicate? That indicates that after losing the third electron, the element must have attained the electronic configuration of an inert gas. Okay, so if it is attaining the electronic configuration of inert gas after losing the third electron, it is indicating that it might be having 3 electrons in the outermost shell. Yes, are you understanding, guys? So how many electrons are there in the outermost shell? 3. So our answer is what? Option 1. That is, answer is 3, guys. Okay, let us solve the next question. Okay, so this question is based on colloids. This question is based on colloids, that is associated colloids. An ionic mishell is formed on addition of option 1, excess of water to the compound given over here, excess of water to this compound, sodium stearate to pure toluene, liquid diethyl ether to aqueous NaCl, liquid diethyl ether to aqueous NaCl. So we have to see how we are getting ionic mishell. How do we get it? Ionic mishells are obtained when you have a compound with a hydrophobic part and hydrophilic part. Okay, you are putting it in water, and as you are putting it in water and the concentration is above the critical mishell concentration, that is when you get an ionic mishell, right? So let us look at this. Excess of water to liquid. Now this is what your compound is. Is it having a SO4 at the end? Yes. So is this part your hydrophobic part? No. That part is hydrophilic. That part is hydrophilic. Now this part what you see over here, this part is hydrophobic. This part is hydrophobic. That is water heating. Right? Okay. So if you are adding water to this compound, this will certainly give you an ionic mishell. This will certainly give you an ionic mishell, right? If you look at the second compound is ionic in nature. Second compound is ionic in nature. It will just dissociate. There is no hydrophobic, there is no hydrophilic part. Third, sodium stearate in pure toluene. The solvent is toluene, so you are not going to get a mishell, guys. Okay. Liquid diethyl ether. That is not possible, guys, okay, because it's an organic compound. It is not going to dissolve in water. It is not going to combine in water, guys, right? So this part over here that you see is hydrophilic. This is hydrophilic and this part over here is hydrophobic. Therefore your answer is 1, guys. Therefore your answer is 1. Okay, is that clear, guys? A very easy question, guys. Okay, so if you are thorough with the concept of associated colloids, then you will be able to crack it very easily, guys. Let us go on to question number 15. Okay, so a question from coordination chemistry. Okay, let's look at the question, guys. The d electron configuration of RuEn thrice Cl2 and FeH2O6 Cl2 respectively are. First of all, what is En? En is ethylene diamine. Okay, it is a bidentate ligand. it is a strong ligand. It is a strong ligand. H2O, water, it is a weak ligand. H2O water is a weak ligand. Okay. So what we have to write is, we have to write the electronic configurations in the crystal field splitting state. So how do we go about it? Let's see. So if I look at the atomic number of Ru, what is the atomic number of Ru, guys? Atomic number of Ru is 44 and atomic number of Fe is 26. So there, what is the oxidation state of Ru? En is a neutral ligand, Cl2 is carrying a charge of -2. So here the charge will be what? The charge will be +2. Fe is again having a charge of +2. So Ru in the +2 state, will have a 3d6 electronic configuration, and same is applicable for Fe. So now we'll look at how to split these electrons between the T2G and the Eg orbitals. Okay, so let us split the orbitals, guys. So we have 3 orbitals over here which are T2G and 2 orbitals over here which are Eg, right? So 6 electrons, strong ligand field, right? So how will I distribute the electrons? All the 6 electrons will go where? They will go into the T2G orbital. So here I will have 1, 2, 3, 4, 5 and 6 electrons. So all the electrons going in what? Going into T2G. Okay. So any options matches with this? Yes. Option 1 and option 2 is matching. Now let us look at Fe. Is Fe2 plus matching with any of the options? Let's see. So Fe, we have what? Fe in the +2 state. We have, let us split these orbitals. So if we are splitting this, again we have T2G and Eg. Is it a strong ligand? Is H2O a strong ligand, guys? Is H2O a strong ligand? No, it is a weak ligand. If it is a weak ligand, then how will I put the electrons? I'll put the electrons as 1, 2, 3, 4, 5 and 6, right? So in the T2G I have 4 electrons. In the T2G I have 4 electrons. In the T2G I have 4 electrons and Eg I have 2 electrons. So let's see if it is matching with any of the options. Okay, yes. So it matches with what? It matches with option 2, guys. So the answer over here is option 2. Okay, is this understood? Okay, easy question, just that you should know crystal field theory and crystal field splitting properly, guys. Okay, let us go to the next question.